Hey there. Have you ever wandered down the aisles of a parking garage looking for an open space? You shouldn't have to waste your time that way when you're just trying to get somewhere on time. Do you own a parking garage and wonder what the occupancy is at any given moment? Did you build the garage big enough to handle the midday parking rush? You don't have to wonder anymore. Why not use sensors to detect which spots are open and signal drivers with a green LED above open spaces? And while we're at it, why not use a smart Internet of Things controller to update a cloud monitoring solution with the current parking garage occupancy? Hi, I'm Sam, and I'm going to tell you about Amon and Benjamin's smart parking garage demonstration. They built this project for their embedded systems design class. It's a prototype designed with tape, cardboard, glue, some electronic components, and creativity. The heart of the project is a Texas Instruments CC3200 microcontroller. It's an ARM device with a dedicated Wi-Fi chip for keeping it connected to the internet. That's how it keeps the cloud monitoring solution up to date. Most of the electronic sensors communicate with a protocol called I2C, and I'll come back to that in a minute. The OLED screen used to display the parking space status uses SPI as its communication protocol. For proximity sensors, they used an IR light sensor suited for the scale of the project, but you'd probably want a more expensive LiDAR sensor in a real parking garage. Because all of the sensors share the same I2C hardware address, there's also an I2C protocol multiplexer to enable communication with only one sensor at a time. The LED status lights are on a simple 5-volt circuit with single-pole double-throw analog switches deciding which light, red or green, gets to be lit for a given space. Because there are way more LED lights than the microcontroller has GPIO pins for, they used an I/O expander which also communicates via I2C for updating the control signals to the LED switches. On a project this ambitious for completion in a week and a half, there's always an extra unexpected challenge involved. On this project, that unexpected challenge was I2C communication with the proximity sensors. Sometimes, and without any warning, a proximity sensor would pull the data line low, refuse to acknowledge a transmission from the brains of the project, and cause the entire project to freeze up waiting for it. The library in use for I2C communication didn't have a reliable timeout in the case of a NAC, or no acknowledge interrupt. In order to have a reliably working project, Ben and Amon would have had to completely rewrite the I2C library and its error handling to be more resilient to malfunctioning sensors. A completely stable project would have probably taken an additional week of coding and troubleshooting. So, to summarize this project, a combination of sensors, internet-connected controllers, and engineering can create the ultimate smart parking garage system. No longer do drivers have to hunt for an open spot, and managers don't have to wonder anymore about the occupancy rates of the structure. If you would like to hire either Amon or Ben, they are open to offers and wouldn't mind chatting with you. Just fill out and submit the form on the bottom of this page to get in touch.